Hello everyone. Before we dive into today's topic, we want to take a moment to thank you for your support. Every like, comment, and subscription truly makes a difference and helps this channel grow. If you enjoy our content and don't want to miss upcoming videos, subscribe to the channel and hit the bell to receive all notifications. In the most remote silence of the solar system, where the sun's light is but a whisper and the cosmic night seems eternal, something is stirring. It's not a falling star, nor a wandering asteroid. It is an ice giant, a celestial body so immense it defies every previous discovery. A comet so vast that, if placed on Earth, it would span coast to coast. For now, its name is merely a designation. See 2014 UN271. But behind that combination of letters and numbers lies one of the most extraordinary mysteries of our time. This comet is no ordinary visitor. It is a colossus born in the depths of the Oort cloud, that spherical region surrounding the solar system that harbors billions of icy nuclei, fossil remnants of planetary formation. See 2014 UN271 stands apart for one fundamental reason: its size. With an estimated diameter of roughly 135 kilometers, it is larger than many moons of the outer planets. It's at least 10 times bigger than the average comet observed so far, and 100 times more massive. Not a streak of flame speeding through the sky, but a mountain drifting through the void of interstellar space. Though discovered in 2014, it wasn't until 2025 that astronomers could observe its details more clearly, courtesy of the ALMA radio telescope in Chile's Atacama Desert. This instrument, among the world's most powerful for detecting millimeter waves, revealed something astonishing: jets of carbon monoxide erupting from the comet's surface, even while it remained about 17 astronomical units from the Sun, roughly the distance of Uranus. This is nothing short of sensational. It means the body is so large and rich in volatile substances that it can begin waking up its cometary activity much earlier than expected. Normally, comets become active only when drawn closer to the Sun, well within Jupiter's orbit. Gas emissions at such distant ranges suggest a composition exceptionally rich in primordial materials, preserved for billions of years in the cosmic freezer of the Oort cloud. It's as though C. 2014 UN271 were a time capsule, a flawlessly preserved chemical archive ready to unveil the secrets of the solar system's birth. Each evaporating particle, each molecule released into space, speaks a word in that story. And there's more. The comet's size isn't merely a statistical curiosity, it changes the entire game. Such a massive body not only endures numerous close passages to the Sun, but could also harbor measurable quantities of stable and unstable isotopes, like deuterium, carbon-13, or oxygen-18, accessible with today's instruments. These isotopes can reveal the chemical-physical conditions in which the comet material formed, offering precious clues about the protosolar nebula from which the planets emerged. Scientists hypothesize that massive comets like this may have been key carriers of water and organic compounds to primordial Earth. In other words, they might have been crucial to making our planet habitable. If that's the case, C. 2014 UN271 isn't just an object to study. It's a key to understanding our own origins. The present moment is particularly favorable for studying this object because it's in a critical phase, steadily approaching perihelion, the point in its orbit closest to the Sun, expected around 2031. That means that in the coming years, we'll witness its activity grow exponentially. We'll follow, in real time, the transformation of a body that for eons slept at the dim outskirts of the solar system and now awakens, emitting vapors, gases, and perhaps even solid fragments. This gradual approach gives us a rare opportunity. We can plan increasingly precise observations, involving ground-based telescopes, spaceborne probes, and possibly even dedicated missions. There's already talk of proposals to send a robotic vehicle on an intercept trajectory, aiming to study it up close or even land on its surface. A complex endeavor, certainly, but not impossible, especially following the success of ESA's Rosetta mission to the famed Comet 67P, Churyumov-Gerasimenko. But comparison is hardly fair. See, 2014 UN271 is vastly larger, bringing logistical and physical challenges, but also offering far greater scientific potential. Every square meter of its surface could contain information about cosmic chemistry never observed. Every meter below could hide pristine compounds, never yet exposed to sunlight. Yet perhaps the most captivating angle is the narrative one. This is not just a comet, it is a time traveler. A silent witness to epochs before planets existed, when the sun was merely a forming star, wrapped in a rotating cloud of gas and dust. It is as if a messenger has emerged from that primordial mist to bring us a fragment of the past, a signal from an era forgotten. And as this giant continues its descent toward the inner solar system, the eyes of astronomers, and soon, of the world, will remain fixed upon it. For in that distant glow, preparing to become a visible comet, we may find answers to questions that have accompanied us forever. Where do we come from? How did life form? And how much of our present is written in the ice of a time beyond time? It's easy to be spellbound by such a vision. So remote and silent an object, traveling for billions of years in interstellar darkness, now poised to take center stage on the celestial scene. But the real question is, what can it tell us, tangibly? To scientists, see, 2014 UN271 is far more than curiosity. It is a natural experiment, a time capsule that can reveal the chemical evolution of the entire solar system. And to accomplish this, we must seize every observation opportunity. Every slight movement, every change in brightness, every variation in the developing comet's composition. Early data from ALMA have already revealed something surprising. The comet emits carbon monoxide in quantities that defy predictions. This is significant because CO sublimates at very low temperatures, and its abundant presence suggests the comet is heating unevenly from within. It may have a porous core with internal channels facilitating gas release. Or, in an even more fascinating scenario, it could be geologically more complex than expected, with regions rich in volatiles and others that are more stable. The behavior of c. 2014 UN271 forces us to reconsider some of our beliefs about giant comets. For instance, what defines the boundary between comet and planetoid? When a cosmic body reaches this scale, it becomes hard to draw clear lines. Some astronomers wonder if it might be more accurate to define c. 2014 UN271 as a hybrid object, an evolutionary link between small comets and planetary cores. In other words, it might be a surviving fragment of outer planet formation, a quasi-planet, that never fully formed, frozen at the system's edge for billions of years. Its orbit is itself a fascinating mystery. Its path will graze the inner solar system without ever threatening Earth. Its closest approach will remain beyond Saturn's orbit, but the inclination and ellipticity of its trajectory point to a deep Oort cloud origin. That debris reservoir, suspected but never directly observed, represents one of modern astronomy's most enthralling frontiers. Each object born from it is an emissary, a natural sample of the conditions prevailing when the Sun was newborn. And what if we could not only study it from Earth, but observe it up close? Current technologies, enhanced by past mission successes, could in theory intercept its path with a robotic probe. Such a mission, if green-lit and funded in the coming years, could arrive just in time to witness c. 2014 UN271 at its most splendid, delivering high-definition imagery, in situ spectroscopic analyses, even surface drilling. A titanic undertaking, but one of the most extraordinary in the history of space exploration. In the meantime, public and scientific interest grows day by day. Every new image, every detection, every slight shift in the comet's activity becomes a subject of study, discussion, wonder. Because within this object lies more than science. There is a poetic, almost mythological dimension. An entity traversing deep space, invisible for eons, now drawing near, slowly but surely, toward the light. The comet's visibility in the night sky, anticipated over the coming decade, could gift us a majestic spectacle. It's not certain that it will become naked eye visible. Much depends on how much volatile material it emits. But even without a bright coma visible from Earth, its scientific value remains immense. Observations in radio, infrared, and ultraviolet bands are already constructing an increasingly rich and complex picture. Every piece of data collected adds another tile to this cosmic puzzle the comet represents. And then, there's the sense of wonder. That feeling that has propelled us since ancient times to gaze at the heavens and ask, what's out there? Where did we come from? See, 2014 UN271 won't answer these questions on its own, but it will give us new tools to search for answers. And perhaps, on that journey through ice and silence, we'll discover something not only about the cosmos, but about ourselves. Because every comet that crosses the solar system is a message. A fine thread binding us to a remote past, to a time when life was merely a possibility written in molecules. And today, as we observe that distant light slowly growing in the sky, we can feel part of something greater, an ongoing cycle that includes us, precedes us, and transcends us. Thus, the silent giant continues its course. Slowly, but with resolve, C. 2014 UN271 reminds us that the universe is not only emptiness and distance, but also memory and revelation. And that sometimes, to understand who we are, all we need is to gaze at a comet and listen to what it has to say.